Today, class, we're going to talk about congruence and symmetry as it applies to plane figures. Can anybody tell me what a plane figure is? Jason?
Plane figure exists on a single plane.
That's right. Okay, so now we're going to try to figure out how the congruence and symmetry works on that single plane. Now, we've already talked about congruence in a former class, so can somebody define congruence for me? Anybody can define congruence? Jason?
Deciding exactly when superimposed.
That's right. So if something sits on top of one another and it's an exact replica of it, that means that it's congruent. Now, yesterday we started talking about symmetry. I gave you a definition. Can somebody tell me what that definition of symmetry is? Yes, ma'am.
When one shape becomes exactly like another through the use of transformations.
That's right. And what are those transformations?
Rotation, reflection, translations.
Okay. And rotation means that we're going to turn it. Translations mean that we're going to slide it. And reflections means that the image flips. So, to begin with, I'll show you how to use transformations to prove congruence. Then I'll show you how to find the different kinds of symmetry with transformation. Let's get started on congruence first. All right, let's look at figure 1 on your sheet of paper that you have. And I have a set of parallel lines that are cut by a transverse, correct? All right, now I've labeled those angle 1, 2, 3, 4, 5, 6, 7, and 8. Now, I know that principle tells us that 1 and 4 are congruent, 2 and 3 are congruent, 5 and 8 are congruent, and 7 and 6 are congruent because of vertical angles. Is that right? Is that what we've already learned? Okay. Now, we also know that alternating interior angles are congruent. So 4 and 5 are congruent, and 3 and 6 are congruent. Now, I want to be able to show you how to prove this congruence with transformations. So, everybody has a piece of patty paper. I want you to take your patty paper, and I want you to, first of all, take and make a line and trace the angles 1 and 2 and 3 and 4 for me on your patty paper. Are y'all done? Okay, first of all, we're going to use a translation or a slide. So if we take your patty paper with your drawing on it, and we slide that patty paper down your transversal, do you find that 5, 6, 7, and 8 are congruent to 1, 2, 3, and 4? All right. Now, another thing that we can prove is take and move your paper back up where it was to begin with. And then if we rotate your patty paper, if you'll put your pencil right in the middle of the vertice at 1, 2, 3, and 4, and if you'll take and rotate that around until angle 4 is laying on top of angle 1 and angle 3 is laying on top of angle 2. So we have just proved that vertical angles are congruent because those lines are superimposed right on top of each other. Now, we can also prove the theory of alternating interior angles. Now that we have that moved down, if you'll slide that down your transversal again to the second vertice, we have angle 4 sitting on top of angle 5, do we not? So that proves our theory of alternating interior angles. Angle 4 and angle 5 are congruent, angle 3 and angle 6 are congruent. But also we showed that vertical angles are congruent through this. So y'all are able to see through the use of translations or slides and rotations that we were able to prove congruence. So it's not just something that y'all are hearing in a classroom, it's something that you can actually see and have it proved to you on paper. All right, now that we've talked about congruence in plane figures, we're going to go ahead and start on symmetry of plane figures. First, there are two types of symmetrical, there are two types of symmetry, excuse me. There's reflection and there's rotation. Rotational symmetry is found if and only if it can be rotated more than 0 degrees and less than 360 degrees so that its images coincide with its original position. And then reflectional symmetry is found if a plane divides the figure in half so that one half of the figure is a mirror image of the other. Now let's put those symmetry tests into motion with figures 2, 3, and 4. All right, so first of all, we talked about rotational symmetry. You're going to take your patty paper again. Gotta get you a new sheet. And you're going to take, and my patty paper isn't big enough for this figure, but on figure 2, I want you to trace all the outline of the triangle, label it, and then draw your lines. Give y'all just a second to do that. Y'all done? Okay, now I want you to look at it, and we've got A, B, C, and A, B, and C, and this is an equilateral triangle. So that means that all 3 sides are equal and all 3 angles are equal. So we're thinking that this should be symmetrical because everything's congruent. But let's go ahead and prove that it's congruent. Or excuse me, prove that it's symmetrical. If you'll take and put your patty paper on the center of where all of your bisectors intersect, and then if you will take and rotate that 60 degrees, counterclockwise or clockwise, it doesn't matter. If you rotate that, you'll find that angle, if we rotated it counterclockwise, angle B will now be sitting on top of the angle, or angle A will now be sitting on top of angle B. Is that correct? Does it line up perfectly? Considering that you drew everything right on. And then if you take and rotate it another 60 degrees, angle A will now be sitting on top of angle C. And that lays on top of it perfectly. So we've only rotated our figure that's on our sheet of patty paper 120 degrees, which is more than enough because our rotational symmetry says it has to be less than 360. So we have rotated it twice, and we haven't come around a full 360 degrees yet, and we've proved symmetry twice. Now that's rotational symmetry. Now I want you to go ahead and get out your mirror boards, and we're going to look at reflectional symmetry or line symmetry. I want you to take your mirror board and line it up on top of one of your lines that bisects that triangle. It doesn't matter which one. If you'll look at the mirror board, you'll see that the triangle, when it's cut in half, creates an exact mirror image of itself, does it not? Okay. So we know that figure A has both line symmetry or reflection symmetry and rotational symmetry. Now let's go ahead and look at figure 3. And this is our rectangle. I want you to take your patty paper and go ahead and make a drawing of figure 3. Are you done? Go ahead and make sure that you have everything labeled.